Hello students, I am Rashmi Vadwa, Assistant Professor of Sant Andrew Institute of Technology and Management, Gurgaon from ETCE department. Student, today's topic is interfacing of analog to digital converter with the 8051 microcontroller. You know the term 8051 microcontroller from first and second unit, and the term ADC is what? Analog signal is converted into a digital signal. Basically, a electronic integrated circuit which transform a signal from analog, that is a continuous signal, convert into the digital form, that is digital signal, or a discrete, or you can say binary, that is in 1001. So that is my analog to digital converter. When there is a, we are talking about the analog signal, they are continuous in nature, they are varying with respect to time continuously, and digital signals are a finite in nature and having a two states only, 0 or 1, off and on. If there is a 0, then 0 and 1, and on and off state, and only वैसे भी दो ही हमारे पास binary numbers होते हैं, that is 0 and 1. So how to convert analog signal to digital signal? This is the block diagram on the screen. This is my sample and hold circuit, S and H. This is my S is my switch and C is my capacitor. When you are giving an input analog signal, that is U T with respect to T hai. So after sample and hold circuit, you will get the samples like in this continuous signal, like this: sample, hold, sample, hand, hold, sample, hold. And after the putting into the quantization and encoding signal, you will get the output signal, that is D0 to D1 up to Dn minus 1. Next is why we need ADC. What is the requirement of analog to digital converter? Basically, analog signals is an microphone input, ADC, that is a digital signal is for DSP, digital signal processing, DAC, and then you will get the analog signal speaker out, microphone in, and speaker output. Basically, microprocessor and microcontroller or any digital system can use perform complex programming or a complex processing on digitized signals. When the signals are in the form of digital, they are less susceptible to the delicious effects of the additive noise. So when we are using this ADC, it provides a link between the analog world of the transducer and the digital world of the signal processing and data handling. So this is the requirement of analog to digital converter. This is the pin diagram of ADC. A0808 और 0809 हम कोई भी ADC ले सकते हैं. There are the 28 pins having first 1, 2, 3, 4 and 5 as a pin IN input port 3, 4, 5, 6, 7. And on the 28, 27, 26 side, IN0, IN1, IN2. Then on the pin number 6, this is the SC, EOC, D3, these are the data lines, clock, VCC, V reference, ground, D1, D2, then V reference, and this is again D0, D4, D5, these are data lines. This is my add A, add B, add C, and this is my ALE, address latch enable. So these are this is the pin diagram of ADC 0808. Next is what is the feature of this IC, this pin diagram के जो features क्या हैं वो क्या है? 0808, that is a 28 dual in package, resolution 8-bit, 8 input and output channels, sample rate 10K SPS, and successive approximation technique is used in this IC. High accuracy, high conversion speed, 8-channel multiplexer and latched control logic. Clock frequency 10 kilohertz to 1280 kilohertz. Use clock frequency is 640 kilohertz. Latched tri-state output, and the IC internally consisting of a comparator, SAR and DAC, etc. Basically, SAR is a successive approximation register. So after that we will discuss what is the working of the successive approximation register. This is a one of the type of analog to digital converter. This is the signal description. IN0 to IN7, these are the inputs for the 8 single-ended analog input to ADC. ABC is a 3-bit binary input to select one of the 8 analog signals for conversion at any time. ALE is an address latch enable and used to latch 3-bit address input to an internal latch. ST8 is start of conversion pulse input, and to start ADC process, the signal should be asserted high and then low. This signal should remain high for the at least 100 nanosecond. There is a clock input, and the frequency of the clock can be in the range of 10 kilohertz to 1280 kilohertz, and typically clock input is 640 kilohertz. V reference plus and V reference minus, that is a reference input voltage. The positive reference voltage can be less than or equals to VCC, and the negative reference voltage can be greater than or equals to ground. Therefore, D0 to D7, 8-bit digital output, and the reference voltage will decide the mapping of analog input to digital data. Next is EOC, that is the end of conversion. This signal is asserted high at the ADC to indicate the end of conversion process, and it can be used an interrupt signal to processor. O is the output buffer enable. This signal is used to read the digital data from output buffer after a valid EOC. And then for VCC, power supply, and ground power supply for 0 volt. So ये वो जो pin description थी starting में, ये उनकी explanation हो गई. नेक्स्ट इज द एडीसी टेक्निक बाय सक्सेसिव अप्रोक्सीमेशन. अभी हमारा एनालॉग टू डिजिटल मेथड, हमारे पास 4 टाइप्स के एनालॉग टू डिजिटल होते हैं. दैट इज अ ड्यूअल सक्सेसिव अप्रोक्सीमेशन, पैरेलल, दैट इज आल्सो कॉल्ड एज फ्लैश वन, and a counter type. So out of 4, this successive approximation is the one method for analog to digital converters having a 8-channel multiplexing analog switches. Here address latch and decoder. This is my successive approximation register, control and timing. This is a comparator which compare the two voltages, which one is coming from this analog switches and another from this switch tree, that is 256R resistor ladder, and then tri-state output latcher buffer having a 8 output. This timing and a control is for start and clock, and then and of conversion, that is an interrupt, and this is with OE output enable. So how we are doing a interfacing of ADC 0809 with 8051. So there are the 4 steps for interfacing. That first, the controller select a channel address through port P0.0 to P0.2 port lines. Then port 0.3 is asserted high, and then a low signal to latch address in ADC. Now in the second step, the ADC conversion is initiated by asserting SOC as high and the low through port 0.4 pin. Step 3, then controller keeps on polling the status of EOC through P0.5 to verify whether it is set to 1. Step 4, find the controller. When the controller finds a valid EOC, that is if 1, then it will read the digital value from the output buffer by sending a logic high enable signal through P0.6 pin. These are 4 steps. This is the circuit diagram. See, this is my LCD display. These are my data pins. This is my VSS, VE, RE read signals. This is my 8051 microcontroller. See, having a ports P 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. This is my ABC, ALE, SC, and of conversion, OE, ADC. जो पिन की डिस्क्रिप्शन हमने यहाँ करी थी, ये वही सारी पिन यहाँ पर यूज हुई हैं. और ABC क्या है? 3 binary input to select one of the 8 analog. This one. So this is my ABC. जो select करेगी one of the 8 input out of 8. One of 3 inputs out of 8. So this is my D flip flop, Q and Q bar clock. And this is my crystal oscillator having a 11.052 megahertz frequency. 2 capacitor, 33 picofarad, 33 picofarad, and 5 volt VCC. This is 5 volt supply, 5 volt. Then temperature sensor LM335 is used. This is my analog input. 1 microfarad computer, sorry, 1 microfarad capacitor is used. And this is my converted digital output, that is D0 to D7 from P10 to P17. So using these steps, well, first the controller select a channel through P0 port to this P0 to P0.2. This one is my port lines, this one. And then step 2, ADC is conversion initiated by inserting SOC as a high and low through port 0.4 pin. This is my port 0.4 pin, and this is asserted low. Here 10 kilo ohm resistance, 10 kilo ohm resistance, and VCC supply. This is a circuit diagram which is important for the interfacing. Next is, this is my successive approximation method. Basically, successive approximation is using a comparator and DAC. From this DAC, it converts the digital data into analog. Here, analog input and the reference analog input is compared by this comparator. यहाँ से जो भी analog आएगी, that is my and डिजिटल टू एनालॉग कन्वर्टर. तो यहाँ से आपको एनालॉग आएगी, यहाँ से आप एनालॉग इनपुट देंगे, दोनों एनालॉग का इनपुट का कंपैरिजन होगा. व्हेन V input is greater than the VR, then the output of the comparator is 1. When V in is less than VR, then output of the comparator is 0. This is end of conversion. This is start of conversion clock, successive approximation. The IC consisting of a successive approximation resistor, comma DAC and a comparator. This DAC and this comparator. Output of SAR is given in an n-bit DAC, and the equivalent analog voltage, output voltage of DAC, VD is applied to the non-inverting input of the comparator, and the second input of the comparator is known as the एनालॉग इनपुट. यहाँ से जो दूसरी इनपुट आएगी वो एक एनालॉग इनपुट है, और यहाँ से जो आएगी वो हमारे को डिजिटल टू एनालॉग कन्वर्टर की आउटपुट होगी. And the output of the comparator is used to active the, अब यहाँ से जो comparator की output होगी, that is used to activate this successive approximation logic. And when the start command is applied, then SAR sets the MSB to logic 1 and other bits are made logic 0. So the trial code becomes the 1000. So starting से यहाँ से जो code आएगा 1 0 0 and 0, and so on the process continues. Now to formula calculating the step size and the distance filter, two formulas are there to calculate the Q step, that is V reference upon में 2 raised to power n. N is हमारे पास total number of input lines, that is 2 raised to power 8. So V reference is a V reference plus minus V reference minus positive reference minus negative reference हो जाएगी, और 2 raised to power 8 हो जाएगा 256. And the digital data correspondingly to analog input voltages, digital data which is equals to the V input upon में quantized step minus 1. Now this is the step size, and then the step size is the voltage difference between one digital level and the next one. For example, if ADC has a step size of 1 volt and input of 1 volt will produce an output in a 4-bit converter of 0001. 0 volt is always be considered as 000. So when the voltage level 0 and between 0.62, the binary representation is this one. When 0.6 to 1.25, binary representation is 001. So the step size of 1 volt and an input of 1 volt will be produced an output, and this is a 4-bit converter, and so on, and you will get 111 binary. Next is ADC application. So signal goes through from transducer. This is an electrical signal, pass through electronic procedure, and then you will get the transmitter through electromagnetic wave, passes through receiver, and again electronic signal, transducer. So transducer on the transmitting side and transducer on the receiving side, and signal is received on the receiving side. This is one more application. Scanner and recording a voice. Scanner, when you scan a picture with a scanner, what scanning is doing is an analog to digital conversion. It is taking the analog information provided by the pictures and converted into the digital form. This is the mic having using op-amp, and then analog to digital converter and flash, that is SD card. Recording a voice, when you record your voice or use a VoIP solution on your computer, you are using analog to digital converter to convert your voice, and which is analog into digital information. It is all about the analog to digital converter or interfacing of analog to digital converter with 8051 microcontroller and with their applications. So thank you, student. In next video we will discuss about digital to analog converter. Thank you so much.